Hello everybody, and welcome to part 2 of rendering 5,000 unique animations overnight. If you missed part 1 is called The Power of ST Maps. And that video is also available on the YouTube channel as well as our social media platforms. And of course, our website, stage3vfx.com. Quick recap on part 1. Our main challenge was to get this done, rendering out 5,000 unique animations without waiting forever for renders to come back. I can't imagine how long 5,000 renders would actually take inside of Maya. We also wanted to make sure that we were going to get something really unique in each movie without time-intensive 3D rendering and still have that element respond to the environment and lighting, and that's what we did in part 1. Part 2, now we're going to actually queue up and render 5,000 unique variations of this promotion without accidental repeats. That's really important. They all have to be 100% unique. And the best part, firing off all 5,000 of these with one click. Now, of course, there's a little prep time ahead of time, so we're going to build a tool to allow us to actually do that, so we're not sitting here hitting render 5,000 times and making sure we have the right stuff. Let's let the computer do all the work. And for that, we are going to write a quick Python tool in Nuke. So let's take a quick look at the animation and see exactly what we need to build here before we actually just start writing a tool. You always want to make sure you have all the requirements in mind so you don't lose anything or miss out on any important step. This is on the PainMaker Chris Jericho animations. And of course, we want to bring to life one of the panels of the comic book, the Laser Lab. So the breakdown of how we did it, what is the movie made up of? There are 3 camera cuts in each variation. Those camera cuts are made up of 3D renders, which resolve to a unique comic book cover. The 3 main parts can be referred to as shot 1, the establishing shot, kind of looks like this one down here, or a variation of that establishing shot. Shot 2, the panning shot. We kind of focus in on something interesting in the laser lab and then kind of move back towards over to the laser core. And then of course, part 3, the resolution shot. And that shot right over here is the shot that ends up looking at a unique comic book cover. Those comic book covers all drawn up by John Gardner. So in our demo version, our first shots kind of look like that. We just did a quick demo, a little proof of concept. But now let's actually create the guts of this thing. So what makes up the uniqueness of this? Well, 2 parts. The first part is the 3D renders. We just didn't want to have the 3D renders repeat constantly over the same 3 shots. So we took these 3 shots and we made 5 variations of each of these 3 shots. So there's 5 establishing, 5 panning, 5 resolution shots. And that will combine and make 125 different movie combinations, different movie variations, if you kind of swapped all the numbers up. 125 different variations of this is a far cry from the 5,000 that we actually need, right? And I'm going to get to that here in a second. So the demo took about 12 hours to render in 3D. To create 15 of these would be about 48 hours on our current software, current farm over here, which is not too bad. But if you extrapolate 15 renders all the way to 5,000 renders, I mean, you're talking about, I don't know, it's 400 days of rendering. I don't know the exact math. I'm not going to figure out the exact math, but it's far more time than we had. So the first thing we're actually going to do is create on an external file a matrix of all the different combinations that can occur. So a huge part of the uniqueness without 3D rendering, of course, is putting in a separate comic book cover on all this stuff. So we kind of put this in, and we learned how to do that in the last video with ST Maps, making sure that it still adheres to the environment lighting and all that good stuff. Now, all these things are still separate, but building this modular format, we had the covers in Nuke, and it only takes moments to render, which we'll see here in a second. If we use all 350 cover variations that John drew up, that's potentially 47,500 different movies. We don't need that many, okay? We just want about 5,000. In our case that we're gonna just do right now, we could actually use about 300. Let's use 300 of them or so. So let's get started creating that external matrix file. So the first thing we're going to do is we're going to open up an Excel spreadsheet here in Google Drive. Everybody has Google Drive. It's free. And like I said earlier, if we want to come up with the animation variations for just the 3D renders, well, it's 5 times 5 times 5 gives us 125. So we need at first 125 unique combinations for the movie file itself. And it's pretty simple to do. I'm just going to go over here, and we could just assume this is shot 1, this is shot 2, and this is our resolution shot, shot 3. And The reason why I'm doing this in a spreadsheet is we could have the computer code generate 5,000 unique animation matrices or 5,000 unique animation combinations for us on the fly. But what happens if the computer crashes or we lose power or who knows what can happen in the middle of rendering all these? Well, if it crashes maybe 99% of the way through, you have to start this over again, and now you're not sure because you're running that code instance again, whether you're getting duplicates or not. If we have it all written out into a spreadsheet or a matrix, we know there are no duplicates, and if it crashes in the middle of it, we could always just start it right off where we left off. So now that we know that this is all gonna be shot 1, shot 2, shot 3, we can make one more column over here, and maybe this is the covers. Okay, so each cover is going to have a number assigned to it as well. If every shot is a variation of 1 to 5, well, we can certainly just put a quick little formula in here that generates a random number for us. And that formula is simply equals rand, R-N-A-D, between, B-E-T-W-E-E-N, and then parentheses 1, 5. Okay, and then just hit enter. It's going to give you a random number between 1 and 5. Simple, right? Now that that's done, let's actually just grab the little handle here and drag this same formula to the other shots as well. So now we have random 5, 3, and 3 so far. So far, so good. Okay, now I'm going to grab this handle here and I'm going to drag it pretty far down. If I drag this all the way to, say, 125, I don't know if I have complete uniqueness in here, do I? It could have repeated a whole lot of these. So what I'm actually going to do is I'm going to make sure that there's no repeated elements. I'm going to drag this not to 125 or 204 or whatever I actually copied it to. I'm going to drag this all the way down to something like, I don't know, 600, 700, maybe even 800. I actually copied it all the way to 900. Now, the reason I'm doing that is because I want to be absolutely sure that it generated every single combination of 125 combinations that I could use here, okay? So now that I'm pretty sure after 900 tries, it did every combination, all I have to do is go up to data, data cleanup, and say, remove duplicates. It just analyzes A, B, and C, remove duplicates, and boom. Guess what? 125 unique rows now remain. Piece of cake, right? And that's exactly what we were looking for, 125 unique rows. Now it says 126 on mine because this up here is actually, because row 1 is just our labels. Okay, well, so we have 125 unique rows, but we actually need 5,000 unique rows. And the 5,000 is going to come from the different combinations of the comic book cover. And right now we know there are, let's say 300 of them. John drew 350, but we're going to use 300 of them. So what do we do to kind of divide those up? Simple. If we need 5,000 of them, I'm going to go over to my handy calculator again and say 5,000 of them divided by 300 covers gives us 16.6 rows. Okay, let's just round that up to 17. So I'm going to put 17 rows here for cover number 1. But before I do that, if I just type 1 in here, guess what? It's going to keep re-randomizing all these numbers over and over again. And you don't want to do that. You want to leave them exactly where they are. You don't want to keep repeating that formula or it's going to generate new numbers for you. So I'm going to go and highlight all these numbers again. We basically want to bake these values down so they can't regenerate that formula every time we make our change to this spreadsheet. So I'm just going to copy all these. You can simply just hit copy. And then we're just going to go and paste, but paste the values only, not the formula. Okay, so I'm just going to paste the values. There we go. And now if I make another change somewhere, anywhere in my spreadsheet, it's not going to regenerate that formula anymore because that formula doesn't exist. It's just pasting the values in. It's basically like baking it in. So now, if we want to put our covers in, we're going to use 300 variations of our cover. Every 16.6 rows, I change the cover. Let's round that up to 17. But we're not going to copy paste 17 rows and increment it for 5,000 rows. That's way too much trouble, way too much work. Let the computer do the work. So on the very first cover, I'm just going to put cover 1, just like that. And now we could put another formula in that lets the computer say, I'm going to increment this number 1 time, but I'm going to do it every X number of rows. And that formula right up here is equals integer, int, put 2 parentheses, because we're going to put row, parentheses, D1, end parentheses, minus 1, end parentheses again, divided by, now we're going to do it every 17 rows, so put 17 in there, end parentheses plus 1. It should look just like that. And once you hit enter and that formula is in there, now all you have to do is take this box, grab it by the handle, and just drag that all the way down to that 125th row of your matrix, just like that. And as you can see, every 17 rows, it's going to change that number. But we actually want this to go to 5,000. I'm going to grab this handle and I'm going to pull it all the way down to the very end of my spreadsheet. And the spreadsheet by default should be about 1,000 rows. And there it is. Now mine ends at about cover 59, but it says add how many rows to the bottom? I'm going to add another 4,000 rows to this bottom. Click add, scroll back up to get back to your numbers, and then just drag that down to the bottom again. And we actually ended up at 295 instead of 300 covers. And that's okay because I actually rounded up from 16.6 to 17 rows. No big deal. So now we have all of our covers allotted for, but our shots still don't repeat. But all we have to do is select all of the shots here that go to 125. And we know that if I just copy this 125 row matrix all the way down, we will have 5,000 unique variations of this. So how do we do this very quickly? You don't want to copy paste tons and tons of times again. So here's a quick tip. Select the cells that you want to copy, just like I did, all the way up to the 125th row. Hold down Control and then grab the little blue dot in the lower right-hand corner of the selection box, and then drag this all the way to the bottom, and you will notice that it's actually just going to copy and paste that selection over and over again for you. And there you go. Scrolling all the way back up, you have your complete unique matrix of all the different 3D animations and the different cover combinations that can apply to those animations. Now, some of you eagle-eyed viewers may notice, wait, we don't actually have 5,000 rows, we have 4,999 because this first row right here, that doesn't count, right? Well, you're absolutely right. So what I'm gonna do is I'm actually gonna copy, I'm gonna select all, I'm gonna hit copy, I'm gonna hit paste, so I know all of my values are completely baked in, so I know I won't change anything. Then I'm going to go right up here, click on this row, right click, and I'm going to delete that. You're going to get an error right over here because it's one of the formulas here. So let's actually just change this to a 1, scroll all the way to the bottom, and let's add one more row for 5,000. And it could literally be any combination you want right here. Let's just grab these 3 numbers, paste them right in here because the actual cover will be by itself 295. Boom, there we go. 5,000 unique matrix of different combinations ready to bring into Nuke and render out these. Don't forget, download comma separated values. I'm going to save it right to my desktop and I'll see you in the next part. Okay, thank goodness we're back in Nuke and out of that silly spreadsheet because we're artists and the last thing we want to do is spend time in a spreadsheet, right? But we saved it out and that spreadsheet, the CSV file, is what our Python script is actually going to access. Again, why is it an external file when we could just generate the code ourselves if we wanted to? Because of course, if it crashes, we still have that file and we could just pick it up right where we left off. Every one of those lines in that spreadsheet is actually going to be a combination of an animation that we can use. Before I go any further, let's actually take a look at the tool itself. And after that, then we'll actually break down how we built the tool, which is really just going to be talking about codes of Python. So if you're interested, you can stick around for that part. But if you just want to see how the tool actually works, we'll just get ahead to that right now. So it's called NFT Movie Generator right over here. And it's really just a Python script that I saved out as a separate file and I just copied it right back into place. And how we build this, we'll talk about in a second, but I'm just going to double click on this and you're going to see right up here in the properties bin, we'll give a quick little nickel tour of what this tool does. The very first part of this tool says, hey, CSV file, where is that? Well, that's exactly what we just saved out from Excel, right? It's going to load up the CSV file. It's going to analyze the file, and it's going to tell us a little bit about it, like how many different combinations it can find. Let's do that now. So I'm going to surf over to my desktop, And here it is here on my desktop, 5,000 unique animations matrix, sheet 1 CSV. I'm gonna just click open, and there it is populated in the window, and then I just click this button here that says analyze the CSV file. Click on that, it gives us 5,000 sets of random data loaded. Great. So now that actually just puts it into an array. Now we have a couple other sections of our tool. I built asset paths, read nodes, execute the renders. What's in the asset paths? If I open this up, it says this tool will look for footage in the following paths with the following naming convention. So I adhered to a proper naming convention, and I stuck to that because I didn't want the tool to get confused and not be able to find things it was looking for. So the footage path is basically right here. The comics cover path are basically all the JPEGs of the comic covers that was drawn out is located here, and we could surf over. They're preloaded right now. And then the audio wave path, and all that really is I randomized 5 or 6 or 10 different music files as well to throw in there different mixed down music and sound effects that it can generate as well for a little added uniqueness. But what does this footage path actually look like, and what is it looking for? Well, if I surf over to it, it's all in the script pre-comp folder that I have, and I have a very specific naming convention and folder structure that I like to use for all my jobs, projects, and shows. We'll talk about that maybe another time. But as you can see, there's a couple of folders in here. Cover variations, you can imagine what's in there. I open that up, and here are about 179 different cover variations in there. I could put 300 in there, whatever the case may be, but we used 179 for this one, so that's where the tool finds these. They're just simple JPEGs. Shot 1 variations, 2 and 3 variations. If you remember what I said, every shot has 5 variations to it. So if I go in shot 1 variations, we're going to see at 1, 2, 3, 4, and 5. If I just jump into say shot variation 1, it's just a bunch of JPEGs in there of that shot. Now you might be saying, wait a minute, JPEGs, why are you using JPEGs instead of EXRs? Well, because I knew, number one, that I wasn't going to do any additional color correction on this stuff. I didn't need the dynamic range. I didn't need all the overhead of multi-channel or anything like that. So I made sure that those JPEGs, when I rendered this out, was already color corrected and looks exactly what I needed it to look for, because once this Nuke starts actually rendering all these variations, I didn't want to touch it again. I was just going to upload them to the cloud, and they were going to be done. So that's why all of our renders are actually saved as JPEGs. And also I knew that these are going to be viewed on the web, and the web is simply 8-bit sRGB color space, certain gamma, right? And so the JPEG adheres to that. So there really wasn't a big worry about, do we need to move this to another color space or to another gamma or whatever the case may be. So that explains the footage path and the comic cover path that this tool is actually going to go look. And then of course the audio wave path, you can just imagine, same thing, just going over to audio and in the mixdowns folder. And I just did this in Adobe Audition, and there's just 5 different random audios that it could pick up as well. So that's what these are for. Now, randomized audio using the same naming convention. If you want to change, of course, your paths or whatever, you can certainly put that in here, but it just surfs over and it knows exactly where to find the footage. Pretty simple. Now the read nodes down here, I'm going to open up that. This is where it actually tells you, hey, every piece of this movie, how many frames are in shot 1? How many frames are in shot 2 and shot 3? Well, for this project, I pretty much stuck to the same frame count for all the shots variations, but I wanted to have a little bit more modularity here. I wanted to have a little bit more future proofing on this tool if I needed to use this tool again. So I could change variations. I could say, look, don't include a comic cover, or only include shot 1 and 2, or maybe we don't need a 3rd shot in there. So I could turn these off and on, and I could change the values of how long or how short these shots actually were. And it needs this information so it knows when it puts this all together inside of Nuke, it's going to make one movie file. And then it has a generate read nodes button. We'll get to that in a second. And down here it has, of course, execute the renders. Well, let's just hit the generate read nodes button now. For a Python script to generate and connect read nodes automatically, that's really pretty simple, and I'll show you how to do that here in a half a second when we go into the detail of the code. But clicking on the generate read nodes basically builds this structure here. And as you can see, pretty simple. Let's just open this up a little bit bigger so you can see it. Here's shot 1, shot 2, shot 3, basically just A's over B's, right? Right over here, we mask in the actual comic book cover. Here it is here. The ST map, which of course we talked about in part 1 of this. Right over here, the UVs. Instead of going back and changing any of the renders, I just tweaked the UVs a little bit, played around with the alpha, made sure all this was consistent across the board, reformats it, puts it right on top of the element here. And if we just put our viewer on top of this, you'll see here's the comic book cover. Shot 1 is going to be back here in the 0 to, 100 frame range. Shot 2 right here in the middle as it scrolls through that. Shot 3 right up here in this range. And as you can see, instead of rendering it as 50% gray, I rendered it over as black and then masking that in. Here's the cover right here. Make sure our project settings was set to 1920, 1080, of course. And then this down here is just simply a constant that just gets faded in and out as the show starts right there and as the show ends over there. And the reason why I added the fade in Nuke, not common at all, of course, you would leave that to the edit stage, but there was no edit stage on this because, like I said earlier, I wanted to make sure that what it rendered out was it. I didn't want to touch this project again or go back and have to tweak 5,000 movies or animations again. So I included the fade out right there. And then, of course, the write node right here. Now, the write node is just writing out to an H.264 codec, 24 FPS. The audio file is brought in automatically from the tool, which I'll show you here in a second, and that randomizes that. And so the tool automatically populates the write node here with the different numbers and integers that it needs to keep things unique. So going back to the tool, the execute renders right down here. I could say, hey, if I need to start and stop it or pick it up in somewhere where I left off, maybe we had a power outage or God forbid, whatever the heck happens, and it stopped at movie 3,850, I could say, okay, well, let's pick it up at 3,851. It's just going to access the CSV file right up there, and I could change the render range for every one of these that I wanted to. The rendering matrix down here basically just gives you an added detail that if I wanted to compare what it's actually generating versus the spreadsheet that I may have open somewhere else, I could just simply compare and say, oh yeah, line 3,851 actually does coincide with the matrix that I have right over here to make sure that it's still doing what I expected it to do. Now, I'm not going to render out 1,200 movies here in a second, but what I am going to do is let's just throw a number out here. We'll say 4,560 to 4,562. We'll just render out a couple of these real quick. And if I just punch that in and then just hit begin render, you'll see that obviously it moves very, very quickly. It's going to get to how many frames it needs, 400 frames in just a couple of seconds. So I made sure that this process actually brings down the full render of every movie in 20 to 25 seconds. And that's really all we could afford for your final renders, about 20, 25 seconds or so. Because even rendering at 20 or 30 seconds per movie, which is pretty fast, you still got 5,000 of these to kick out. So if I surf over to the folder where this is actually going, you'll see here is PainMaker 3D Lab version 4,560, which is what it just did a minute ago. Now it's already doing 4,561, that version. From start to finish, at night, you would just start with movie number 1 and end with movie number 5,000 and fire it off and go have a nice dinner. But going back over to what it's actually kicking out, it'll just keep going. And of course, you could throw this on other computers. You could utilize a farm to speed these up as well. But like I said, once the tool is built, you just click once, you walk away, in the next morning, you got 5,000 movies sitting on your hard drive. And just to take a look at what this looks like, and there you go. And it could just keep going, but we're just going to cancel that right there. So now I'm actually just going to show you the code, and I'm just going to zip through the code real quick. If anyone's actually interested in having this tool, I'll certainly send it to you or put it up on the cloud for you. But I'll just do a quick tour of the code for the last part, those of you that are interested in what the code looks like. Okay, quick tour of the code. I don't recommend coding directly in the Nuke, but there is some color coding in the Nuke code that you write, but it's not the most robust IDE, interactive development environment, that you can code with. And you're coding for disparate, separate knobs that interact with each other with global variables, and that's great, but it's oftentimes you're going to find yourself kind of jumping back and forth between knobs that have code to see what you've written here, written there. So, you're switching back and forth a lot in different places. So it's not super efficient. It's not ideal, in my opinion, but I should say, also that I'm by no means not a professional programmer or coder. Okay, I'm an artist that writes scripts. I'm sure there are lots of ninjas out there that can say, oh, if you just do this or do that, you can save, 5 lines of codes and 10 lines of codes or whatever, and that's great. But for the most part, when you're an artist that scripts, you just need something to work and work fast and work correctly. And the efficiency of the code, it kind of takes a back seat because obviously deadlines loom and you just need to get it done. Usually that same day or hour. But just to put that caveat in there, I'm not I'm not saying this is the best way to do it. There's a million ways to do everything. This is the way I did it, and I'm just sharing it with you. But let's look at the full tool as our last part of this quick campfire. In Nuke, I think probably the fastest, easiest way to start creating tool is just use the no-op node, the no operation node. Basically, it's just a blank node. It doesn't do anything, right? You could plug something in, it doesn't do anything. But if you go up here and click, right-click and do Manage User Knobs, you can add all kinds of different elements in here, all kinds of different UI elements, and then add code to those elements, and there you go. While you're adding that, you want to, of course, open up, right-click, Windows Script Editor, and just see what you're doing in there. What I was usually doing is just writing the code in a separate program that'll save it, and then just copying it back in here and testing it. But simplest thing to do with a no-op, just adding some, I need this integer knob. You name it something, you label it something, say okay, and there it is, right? Then you could jump back in here and you can add code to it and things of that nature, right? So looking at our tool right over here, and saving tools and everything, I just use py files, text files that are just named with a py extension, so I know it's a Python thing. And you could literally open up any of one of these things right here in Notepad or whatever other program, Notepad Plus or whatever. Here's what the tool basically looks like all in one. It's not formatted by any means to help you read it, and you would definitely add a lot of indents and spacing in your code if you're doing it in an IDE. But you could just take that and just copy paste it right into Nuke and it's going to work. But just taking a look at some of this code real quick, I'm going to click on Manage User Knobs. Adding this CSV file name, really all this is just bringing in a file name right over here. There it is, file name, and I could just add another one in here. It's just a field that's just going to grab a value. The Analyze button right over here is where actual code takes place. And if I click on Edit here and just make this a little bit bigger so you could see, I'm importing CSV, which is just a package that you can import into Nuke that allows it to read comma-separated values. And then I have a lot of global variables. Random array is the global variable that's holding this. This node is what it's pointing to, this actual tool, and the selected node, and then the path is just grabbing this element here from the UI and just storing it as in the path. If the path wasn't already there, I hard-coded it in there because I knew I needed it hard-coded at the time, but normally I wouldn't hard-code it in there, let you actually choose it. And then it basically just reads it. This is really this part is the most complicated part of the whole script. There's really nothing to it. With the open path, it's going to read the file, it's going to read the headers, it's going to read the data row by row, and it's going to put all of that, basically the CSV, into an array that you can just access. So this node CVs the CSV feedback, he sets the value of the string, and there you go. So you could just set, an index of the array and say, hey, well, what's the index 500 of this array? It's going to give you this array of numbers. And now you know the numbers that you can punch right down in here later on what to access, really. So there's nothing to that. Asset path, really simple stuff. This unnamed here is really just a divider line. Maybe someday they'll have a nicer kind of UI thing here to kind of build these out. But right now, you could just create, a little bit of space here, and some of these things are just blank lines and spacers. Asset path opens up a new kind of pull down here, blank line. 1 and 2, just seeing what these are real quick. This tool will look for footage in the following path. Another blank line, and then the footage path itself, editing it, is basically just the same thing as the CSV. It's just grabbing these things and putting the path into a variable. Okay, and then later on, I'm going to, we assign a variable to the actual UI value in the field, and then you use that variable and you just go get the file. Most of all this is actually just occurring, most of all the code is actually just occurring in 2 spots. The rest of it is just UI inputs, really all it is. The make nodes right over here, if we just click on that, you have 1 shot, 2 shots, 3 shots, right over here. It's just simple UI elements that's just gonna put a value in there. And then the generate nodes is what I was talking about earlier, just taking a look at what this code is here. Just to zip through this, the one-shot box is basically just assigning a variable to whatever value this is. If it's turned on, then one-shot box is a 1. If it's off, then it's a 0, right? And then how many frames, this value, this variable is simply just going to store the value, and I put 100 in here, and it's just going to update it right over here. Not a big deal. And you do that for all the values in here, so you assign all that. And then right down here, there's just some error checking, making sure that the actual length of the project is adding up to how many frames you actually have in here, how many frames you can actually write to. And then right over here, you're just actually creating merges. Merge 1, here's the code to actually just create merge 1. And then you set the input to whatever you've created before. And this is basically how all you're doing is setting up the nodes to connect to each other, right? And then the write node here is basically just setting the knobs, setting the codec that you want, setting the audio file to whatever variable is randomized over there, and basically just creates the nodes for you. You could just click on it again and just regenerates them again. Right down here, the execution, starting movie number, ending movie number, again, just variables. And then of course, the begin render element right over here. I'm gonna make this a little bit bigger. Importing random package, which just allows Nuke to randomize things. And then start movie number. This is just assigning the UI values to the variables. And then right over here, for X in range, this is a simple for loop, which is doing start movie number, end movie number, right? Randomizing the audio. It's the only thing that's actually randomized. Everything else coming from the CSV array, right? So movie popular, there's your random audio. It really doesn't matter. And then populating the matrix with right over here, the random array that we created at the first part of this code is just basically grabbing the proper indexee of the array of our CSV and putting it in the proper locations, right? And then saying, now that I know the index number, I can actually change the path that I'm gonna go get the read nodes with. So the read node was SHA-1 variation 0 plus that CSV value of the array. That's just changing the path over to where it's getting the next part, the proper part of the JPEG sequential frame sequence. That's all you're doing there. And you're setting that for basically all the paths for the 3D renders, as well as the cover path. That's really all there is to that. And same thing with the UV path that we built in. And then, and of course, the new NFT movie name. Just kicking this out, and it's just using the loop number that you've already established right over here as X, MOV, setting the right knobs, executing it, right start and end, and there you go. It's as simple as it gets. You can use this for really anything. So again, that's a quick tour of the code. I'll put it up on my site somewhere so people can download it if you're interested. Or even better, you out there that would like to spend a little extra time in actually making this tool even more modular, even more useful to anybody out there that may need to do something like this. You never know what you're gonna need until you need it, right? So I'll throw it out there for all those people who want to play around with it. I hope you enjoyed this campfire. That's how we created 5,000 movies basically in one night. And I'll see you in the next campfire. Thanks, everyone. Ciao.